Hey guys, so on Friday we left off talking about coal and petroleum or crude oil. We're going to kind of use those terms interchangeably. But uh, you were talking about coal and how it is the dirtiest of all the fossil fuels. Then we talked about petroleum, gas, diesel, etc., and how it's cleaner than coal, but obviously there are pros and cons. It's very energy dense, but it's very dangerous to transport. And as I was screaming at you as we walked out, it seems as though there's a direct correlation between how beautiful a place is and how much oil it has. So that's been an issue with trying to figure out, are we allowed to go and get the oil out of this place because it looks like this. Okay, and so I want to move on and talk about two other sources of fossil fuels. The first, which is called oil sands, and liquefied coal also is going to get grouped into this category. So you can see here in this picture, this guy is holding some oil sand, and basically it is just petroleum that has been mixed in with some sands or clays and water and kind of made into like a goopy paste. We need to make sure that we know what these are and why these are potentially viable. First of all, though, the main component of oil sand is bitumen, which is different than the bituminous, which is kind of annoying, which is that second classification, second oldest coal. So bitumen is like it's the crude oil, but it's not buried. It's been exposed to the surface and it's had oxygen get in it, and specifically it has bacteria in it that have kind of gotten in there and eaten a little bit and kind of decayed and just kind of rotted a little bit inside this oil, and it turns it from being like a straight liquid into this real sludgy, like goopy thing that mixes in with sands and clays and water and just forms like this kind of kinetic sand looking thing. Now, you can take that and purify it and like squeeze the oil back out of it, and that may be a viable thing for us to work on because we don't use this at all. Like, it is not currently utilized for fossil fuel use. So switching to, mining and cleaning of this stuff can expand our fossil fuel supplies. I think the only thing that we use it for right now is we mix it in when we make asphalt. So, like, that is a resource that we could potentially go and, harvest and clean, and that would extend our fossil fuel, resources for quite a while. However, and this is very important, oil sands have a much lower energy return on the energy invested. So it's a pretty common mining investment. As you can see over here, they're mining some oil sands. But the fact that you have to clean it and run it through filters, and it takes a ton of water to actually purify and get the oil out of this like spongy, sandy, clayey nastiness, a lot of times it is just not worth the energy required to get that energy out. And you have to go and get it using pit mines, which are pretty dangerous and they're really environmentally destructive. So it is a potential thing that we could turn to if we needed to, but honestly, like, in my opinion, it's just a lot of work for, like, it's easier to just make a solar panel. So whatever. And then our final fossil fuel that we're going to talk about is natural gas. And I'm going to probably sit on this for a while because we here in Arkansas have huge interplay with natural gas. So technically natural gas is the cleanest of all the fossil fuels. Most of the time, as you can see here, this little red layer is the natural gas. It is mixed in, with the oil, with the crude oil. It all comes from the same place, so you have these little bubbles, and it kind of reminds me of like a fizzy drink. And then as it sits on the underground over time, the gas is going to rise up to the top. So usually when you go looking for petroleum, you will also find some natural gas, and so you can harvest both there, or you can harvest the natural gas and someone else can come in and get the oil. That is how it is most of the time, but it can occasionally be found independently of petroleum, and that is the case most of the time here in Arkansas because we have this really expansive underground shale, which I'll talk about here in a minute. But it goes back to the fact that we used to all be underwater here in Arkansas, and so we have a ton of this natural gas. Okay. So, some of the really great things about natural gas, first of all, it's really easy to get to your home. We have a gas grid almost, kind of like the electrical grid, but for gas. And it's really easy to connect your house into it. This is what that kind of thing will look like. This is a gas meter, and it is just piping up from these gas pipes that are laid underground. It's very versatile in your home. You can use it to heat your home. You can use it to turn your stove on. You can use it in a fireplace. So it's a pretty efficient way to get energy to your home that's not electricity. When you burn natural gas, there are a lot fewer dangerous things in the emissions. Like, obviously still, like, you don't want to huff the smoke from it, but as far as like global emissions go, it's way less destructive than coal. Specifically, it has 40% less CO2 in those emissions compared to burning coal. That doesn't mean that it's like it's the cleanest of the fossil fuels. It's like, for lack of a better metaphor, it's like the shiniest turd. So like, it's not great, but of the other fossil fuels, it is the best. Now, there are a couple of pretty destructive things about natural gas and its use. First of all, unburned natural gas, so just the gas itself, which is primarily made of methane or CH4. Methane is like 80 times more effective at being a greenhouse gas than carbon dioxide is. So you can see here in that graph, sorry, I keep like having the hiccups. So you can see here in this graph, over time, natural or CO2 will build up, and we're looking at global warming potential, which is basically just how good of a greenhouse gas is this molecule. So you can see CO2 over time rises almost, eventually it will hit exponentially, but right now it's more linear, but it rises, steadily. And over time, long periods of time, CO2 will be a more effective greenhouse gas, which means that it will make the planet hotter. But it takes like 370 years to outpace natural gas. You can see that natural gas immediately is extremely effective at keeping heat on Earth, which is currently the problem. Our planet's hot, like unnaturally so. We'll get to that later in the unit, maybe the next one. So while carbon dioxide, like if you opened, a canister of CO2, that's going to be a problem in a couple of 100 years. If you open a canister of methane, that's going to be a problem like next week. So unburned natural gas is a huge issue. So yeah, and again, it's just straight methane most of the time. Now, the final and most Arkansas-centric con of natural gas is that the best way to get natural gas is through a process called fracking. Okay, and here is a picture of a frack well that is in central Arkansas. Anytime that you go to Little Rock, as soon as you hit like Maumelle, Conway, Greenbrier, those areas, you are going to just see dozens, if not maybe 100 of these things down there. Okay. I used to live in Conway when I went to college, and we, like, every time that we drove even like 20 minutes north, you would just see tons of these things. So before I start tearing into fracking, I'll explain what it is, and I'll explain some of the good things about it, and then we're just going to go to town. So first of all, this right here is a picture of shale. It's a type of rock. It's very brittle. It's very crumbly. It's very like, it comes in like sheets. And there is consequently a lot of empty spaces and like little nooks and crannies in shale formations. And shale primarily forms from like leftovers of like lime and stuff like that. So you're going to get lots of little pockets in here that natural gas or previously bacteria and phytoplankton got stuck in and became natural gas. So shale has a lot of little bitty pockets of natural gas in it. Okay, so in shale formations, you will get frac wells, which are these drilling rigs that are hooked up to these giant storage tanks that contain water mixed with some chemical reagents in it. And they will pipe this water down and basically, like a pressure washer, will shoot that water into that shale. Now it will crack and fracture, which is why it's called fracking, will fracture that shale, and all of the gas that used to be in its own little independent pockets, it like liberates that. So then that gas is dissolved in the water and it bubbles back up, and you can then pull the gas out of that water. So it's a really effective way of getting the little bubble pockets of gas out of this shale formation, okay? Now, these fracking chemicals that are in the water are going to include things like lubricants that will help the water penetrate the shale formations. It's going to contain some like dissolving agents that will help, you know, kind of bang through some of the tougher, maybe it's, you know, shale that's got some other stuff mixed into it. It's going to contain, you know, just honestly some chemical agents that will allow that that natural gas to dissolve into the water, so that then they can pipe it back up and then pull it back out. Okay. So here is a map showing some of the locations in Arkansas that we do fracking. We don't have any up here in Northwest Arkansas, maybe like one or two right there, because we're too far north, but the primarily like this region right here. And they used to frack here, they might frack here, but right now it is this central area right here. And then if we were to zoom in on this map, specifically in that central area, you can see Conway's down here, you can see Greenbrier, you can see Pangburn, and Quitman. So you can see all of these are frac mines. So the green means they are currently active, the red means that they are shut down. So there are a ton of currently active frac wells or frac mines in central Arkansas right now. Okay, and you can see that over time, we are this pale, peachy color. We have been increasing over time in the amount of frac wells that we have in Arkansas. Now, it's not, let me make a quick case for it, okay? Because of all of these frac wells in central Arkansas, our gas prices, like your gas bill, has been about 47% lower than without all those frac wells, okay? I mean, here we have just like nationally, our natural gas costs are down 70%. And because it is a local operation, we are generating up to 250,000 jobs in the local area. So fracking is a very economically viable thing that's happening in Arkansas right now. Okay, now let me tear into it. So over here, this like hashed in and then some of the little squares and kind of all this busy area over here, that's the Fayetteville Shale. So it's a big underground shale vein. And conveniently enough, because of the way that shale has all those pockets and all of those like little air spaces, it is very active in the water table. So you can see all of these areas down here, all of this up here, this is all places where there's underground water in Arkansas. We're a very wet state. Okay, now let me go back to that real quick and I'll go to my picture. So you can see here, when they have to drill down and inject that water, they are drilling through our water table. And there's no way to make sure that it is a 100% safe process, so we have a lot of leakage out into the water table. Okay. Also, I'm trying to wrap up here. So before 2008, Oklahoma had about one or two really big earthquakes in a year, or per decade, excuse me. But in 2014 alone, they had 24 really bad earthquakes in 1 year. And it coincides with the uptick of hydraulic fracturing in Arkansas and in Oklahoma. By injecting and cracking that rock down under our feet, they are making all of those rock structures unstable. Okay? And like Arkansas shouldn't have earthquakes, full stop. We're in the middle of the continent. But fracking is making us have lots of earthquakes. So there's a couple of videos I want you guys to watch to kind of get an opinion on and a worksheet